when we make measurements correctly, we end up with a certain well-defined number of digits in the numbers of our measurement. And this leads us to the idea of significant digits or significant figures, which are sometimes called sig figs. That's kind of an abbreviation. And the idea behind these significant figures is that we can use them to help us understand how precisely and in what way a measurement was made. And we can also use them as a guideline for what we can do with a measurement, the numbers in a measurement, when we calculate it. How precise can we make the answers to our calculations? So the first thing we're going to have to do is we're going to have to figure out how to look at a number and count the number of significant figures that are in it. And there are different ways of looking at this. Different textbooks write it down in different ways. And lots of times it's written as a list of rules. And I'm going to give you an example of that list of rules. And you're going to see that it can get a little bit confusing pretty quickly. So, for example, we can count significant figures by keeping in mind that any non-zero digit in a number is a significant figure. And zeros that are between non-zero digits are significant figures. But zeros that are at the beginning of a number, leading zeros, are not significant figures. Zeros at the end of a number with a decimal point are significant figures, but only if the number has a decimal point. Zeros at the end of a number that does not have a decimal point are not significant figures, except they might be marked in such a way that they are significant figures. So you can see there are a lot of ifs and ands and ors in this, and it gets kind of confusing, and we're not done yet. Numbers that are counted exactly have an unlimited number of significant figures. Numbers that are defined exactly, like those in a measurement system, have an unlimited number of significant figures. So there's a lot to keep track of. I've gone through this fairly quickly because we're going to use a slightly different method. Hopefully it's more manageable. It's not that these rules don't work. They are correct. And if you like a list of rules like this, by all means use them. But we're going to look at another system for counting the number of significant figures in a measurement. And we're going to base it on this map here. So this is a map of the continental United States. And usually when we look at a map of the continental United States, it's oriented like this, with north at the top, south at the bottom, east on the right, west on the left. And when we do that, we know that off the east coast on the right-hand side is the Atlantic Ocean. Notice the A in Atlantic is highlighted. And on the left-hand side of this map, off the west coast of the United States, is the Pacific Ocean, and the P in Pacific is highlighted. And that A and that P are going to be important numbers for us. So what can we do with the A and the P? Well, when we look at a number and we want to count the number of significant figures, if a decimal point is present, there's our P right there, we're going to start on the Pacific side, or left-hand side of the number. We're going to look for the first non-zero digit, and we're going to count all of the digits as we move to the right of the number. So let's see how that works. Here's a number right here. It has a decimal point in it. That is to say, the decimal point is present. So we're going to go to the Pacific, or left side of this number, and look for the first non-zero digit. That's the 1. We're going to count that as a significant figure, and we're going to count all the other digits as we move to the right. So we can see that there are 5 significant digits, or significant figures, in this particular measurement. Let's look at this measurement right here. It also has a decimal point. The decimal point is present. We go to the Pacific side. We look for the first non-zero digit. We have to look a little bit because there isn't a non-zero digit until we get to the 1. So we're going to count the 1 and all the other digits as we move to the right, but there aren't any more. So in this number, there's only 1 significant digit. Here's a number that's written in scientific notation. So to do that, we can see that there is a decimal point present in this number. We're going to look for the first non-zero digit on the Pacific or left side of this number. That's the 3. We're going to count all the digits as we go to the right. 1, 2, 3. We're going to stop at the time sign. The power of 10 does not enter into our count. And so this number has 3 significant figures in it. This is a summary of our answer. 5 significant figures, just 1 significant figure, 3 significant figures. What about a number that doesn't have a decimal point? Well, when the decimal point is absent, there's our highlighted letter A. We're going to start at the first non-zero digit on the Atlantic side, or right side of the number, and we're going to count all the digits as we move towards the left. All right, so here's a number that has no decimal point in it. So we're going to go to the right side, or Atlantic side of this number, and look for a non-zero digit. Well, that's 0. Here's a non-zero digit, the 4. So we're going to count the 4, and then we're going to count all the digits as we move to the left. So this number has 4 significant figures in it. No decimal point. On the right-hand side, or Atlantic side, the first non-zero digit is the 6. 1, 2, 3 significant figures. There's another measurement down here, 100,000 kilograms. No decimal point in that measurement. We're going to go to the Atlantic side, that's this side. We're going to look for a non-zero digit. We have to look a little bit. We have to go all the way over here until we find the 1. Now remember, we're going to count the 1 and all the other digits as we move to the left, but there aren't any others, so there's only 1 significant figure in this number. Even though it's a large number, it only has 1 significant figure in it, and that's because of the way it was measured and reported when it was measured. Just 1 significant figure in that number. Here we are, 4 significant figures, 3 sig figs, 1 sig fig. All right, so there's a summary of the how to use the Atlantic-Pacific method to count the number of significant figures in a measurement. Now there are a couple of other situations that we need to be aware of. First of all, if we have a number that has been exactly counted, that number is said to have an unlimited number of significant figures. Let's look at an example to understand that a little bit. Suppose we're in a room with a number of people that we can count. Somebody counted the number of people in a room and wrote down 23 people in that room. Well, that's a number that we can count and count exactly. There's no question of whether somebody rounded that number off. It wasn't ever 23.1 or 22.9. If it was 24, they would have written down 24. So we can say that this is an exact number. That is to say, it has an unlimited number of significant figures. Unlimited sig figs. Let's say we go to the refrigerator and we find that there are 6 bottles of soda in the refrigerator, and we can count them up. Right? So that's a number that we can count exactly. There's no question of it having been rounded off or measured in a particular way, one way as opposed to another way. There are exactly 6 bottles of soda. That number has an unlimited number of sig figs. Here's another situation. Numbers that are exactly defined, and often what we're talking about is the numbers in a system of measurement. We'll see what that means in a minute. When we say that the numbers are exactly defined, we say that they have an unlimited number of significant figures. For example, 1 foot equals 12 inches. Well, in our American or English system of measuring, 1 foot does equal 12 inches. That's the definition of those two things. So if we're using that definition, if we're using a conversion factor, for example, where we're saying 1 foot is the equivalent of 12 inches, or we can write it the other way. We can say 12 inches is the equivalent of 1 foot. Well, in these conversion factors, these numbers have an unlimited number of significant figures because they're defined exactly. There's no question of them having been rounded off. The 1 and the 12 in this context have an unlimited number of sig figs. So here's another similar example. What if we're talking about the metric or SI system? 1 meter can be divided into 100 centimeters. So by definition, there are exactly 100 centimeters in a meter. So if we use a conversion factor, 1 meter over 100 centimeters, or 100 centimeters is the equivalent of 1 meter. In this context, these numbers have an unlimited number of significant figures. They are exact. All right, so what have we done there? We've figured out a way to count significant figures that helps us determine how precisely a measurement was made, and it's going to serve as a guide for when we do calculations. And the calculations part will come up in a different video. So now we have significant figures.